Hi there. Today we're looking at 1.8. This is the last lesson in this chapter, all about all these different types of equations. Today we're focusing on absolute value, and we're going to do both equations and inequalities. When we talk about the absolute value of an expression or even of a number, we're always referencing what its distance from zero is. It seems like we always think, oh, it just makes it positive. But really, by definition, the absolute value is its distance from zero. That could be towards the left or towards the right. How far is it from zero on a number line? To solve it, we're just going to isolate that absolute value. Like in this first example, it's already isolated. And then that absolute value expression is either going to be equal to a positive 12, so it's 12 units away, but for this expression to have been 12 units away from zero, it might have landed at 12. It also might have been at negative 12. We're always going to set up two different scenarios, but you don't do it until the absolute value is isolated. In this case, we're going to go solve, subtract the 5, divide by the negative 3, and x could have been negative 7/3. And that would have worked. Subtract the 5 on this one, and I'm going to be at negative 17. Divide by negative 3, and I get 17/3. If I were to plug 17/3 into this expression right here, it would also work. This one's a little fancier. The absolute value is not isolated, so we must do that first. And just kind of as you would solve any equation, I'm going to get rid of the -2 first, add that to the other side. Then I'm going to divide by that 3. You cannot distribute through absolute value. Those are not parentheses. You cannot distribute. You have to divide it out. Once I get to the stage where the absolute value is all by itself, then you're going to set up two scenarios. When you're setting up your scenarios, this is what gets rid of the absolute value because you're allowing for two scenarios. Either the x plus 4 inside those absolute values equaled 4, and that absolute value didn't do anything, or the x plus 4 in there equaled negative 4, and then you took the absolute value and made it 4. Setting up your two scenarios, x is either 0, on the other side, negative 8, two solutions. Now that's all I'm doing with the equations. We're going to focus mostly on the inequalities today. Now we're going to do the same thing we did with the quadratics and the rationals, same gig every time. Going to do a nice little sign chart. Our to-do list, we're going to isolate the absolute value. The absolute value is either equal to the positive or the negative. Those right there are getting me my boundary points. By solving the equation, that's how you get your boundary points. And then you're going to do your test points in each interval again. In this first example, the absolute value already by itself, just set up your two scenarios. 2x plus 1 is equal to a 7. Notice it's a less than. I'm ignoring the less than right now while I get my boundary points, or it's equal to a negative 7. Subtract the 1, divide by the 2. So 3 is one of my boundary points. Subtract the 1, divide by 2. Negative 4 is my other boundary point. Let's make a number line. Now here, it's a little bit different, I guess. I am not referencing, like with the quadratics, I was referencing these. I truly am going back to this one right here where the absolute value was isolated. If I put in a negative 5 right here, that would be negative 10 plus 1. That's negative 9. I take the absolute value of negative 9 and I get a 9. Is 9 less than 7? It is not. So I'm just going to write no for that. That area does not work. All right, let's try in here. Let's try a 0. If I put a 0 here, I would have a positive 1. Then do the absolute value. So that's still 1. Is 1 less than 7? Yep. So this is going to be a yes. Now let's try 10. Let's get crazy. 10. This is going to be 20 plus 1, so that's 21. Take the absolute value, still 21. That is not less than 7, so that's going to be a no. So wherever I wrote yes is going to be, yep, it worked in that absolute value inequality. I'm solving using interval notation. This is not an or equal to. That means I'm going to be using parentheses, -4 to 3. All right, we'll go ahead and do this one together. Got to isolate the absolute value. That's always the first step. Now, this is going to be the expression then that I continue to use over and over because it is the stage at which the absolute value is isolated. Now, I'm going to set up my two scenarios. Think of it like an equation for now. Set equal to a +5 into a -5. Subtract the 2. Divide. Now, this does not come out very nice. Totally don't care because remember, I'm going to pick nice, pretty boundary or nice, pretty test points. So the boundary points being ugly is no big deal. Oh, this one came out way nicer. All right, now I'm going to do my test points on this number line. I'm going to have a -3/7, a +1, and let's do some test points up in this inequality right here. I'm going to put in, I don't know, let's put in a negative, I try to decide, do you want something close to it or do you want out here? It doesn't really matter. Let's put in a -2. -2 right here is going to turn this into +14. 2 plus 14, that's 16. Absolute value of 16 is still 16. And yes, that's bigger than 5. Got a yes. Let's try 0 in the middle. When I put a 0 here, this is going to be 2 minus 0. Absolute value, it's still 2. 2 is not bigger than 5. Nope. Let's try a 2. That's on the other side of that. We put in a 2. Right here, you end up with a 2 minus 14. Okay, 2 minus 14 is -12. But I'm going to do the absolute value, and it's going to become +12. And 12 is bigger than 5. That's a yes. In this situation, then, I am looking for my yeses. That's going to be here, and it's going to be here. Let's go ahead and write, then, the solution would be from, and this is with a bracket because of the or equal to, negative, no, it's not, hang on. It's going to be a negative infinity, so that's going to be a parenthesis, to the -3/7. That's going to have the bracket, in union with 1 to infinity. Any value within there will work in the absolute value. All right, these might be the shortest notes of all time here. We're on our last slide. And just looking at what some special cases, some things that might happen, and kind of shortcuts for you. This problem right here. Now, I could set this up and do the whole thing, set it equal to a +4, equal to a -4, but I just want you to use some common sense on this one. If you look at this, you're going to take the absolute value of something in here. Remember, when you take the absolute value of something, it makes it positive. What positive number is greater than a -4? Well, all positive numbers are greater than -4. If you get to this stage right here, now you don't decide it until the absolute value is isolated. And if you come across something like this, where you got this positive number, that's always bigger than a negative number. Right off the bat, I would just say negative infinity to infinity. It's one of my special cases. Let's look at this special case. Here I'm taking the absolute value of something. It's going to be positive. And I'm going to say that it's less than -3. All right? I don't think that's a thing. I cannot take get a positive number and say that it's going to be smaller than -3. Will never happen. That situation, we'd say is no solution. Cannot happen. And so you'll have these options on your homework. Okay, last one. You have the absolute value and it's set equal to 0. That's sort of weird because when you set up your two scenarios, now notice this one is an equation. It's not the inequality, it's the equation. When I set up my two scenarios, I set 5x plus 15 equal to +0, -0. That doesn't make sense. You're just going to have one solution point here. So then when you subtract and divide, you only get one answer. There's only one value you can plug in for x to make that play out, instead of two like all the others would have. Those are just some special cases that you can kind of take advantage of, maybe some shortcuts without having to do the big sign chart every time, if you can just use some common sense on these types of expressions. All right, that's all I've got. Good luck.